Welcome back to this video series on the topic of Year 8 Mathematics for Life Fractional Fun. In this lesson, you'll learn how to add fractions together. The way in which we're going to do this is we're going to use a method called the butterfly method. We're going to do this on 4 unique examples. Let's have a look at example 1. We have 7 over 3 plus 3 over 5. The way in which the butterfly method works is we identify our denominators and we multiply these together. Starting off, I draw my vinculum and I multiply my two denominators together, so it's 3 by 5. After which, I put a plus upstairs just like this. Next step, I'm going to get my first numerator and multiply it with my second denominator. This will look like 7 multiplied by 5. Notice I'm using the bracketed shorthanded multiplication here. Same process, it's just written in a more compact form. So this means multiplication, 7 times 5. And then to finish this off, I get the first denominator and multiply it with my second numerator. This will look like 3 multiplied by 3. Next, I have an expression upstairs and an expression downstairs. I simply need to evaluate these. I know 7 5s are 35. I put my plus, and 3 3s are 9. That's all over. 3 by 5, which is 15. Continuing the simplification, 35 plus 9 is 44, and that's over 15. Now if I want, I could try and simplify this. However, I'm going to run into the roadblock in that I know the factors upstairs are 2 by 2 by 11 and 3 by 5 downstairs. And what you see is I can't cancel any of these out. So what that means is we're in our simplest form over here. So that's as far as we need to go. So that's an example of how we add two fractions together using the butterfly method. Now let's have a look at one degree of difficulty higher. We have 5 over 4 take 2 over 3. Notice we're not adding anymore, or at least at first glance we're not. But let's make it such that we are. We start off by writing the fraction 5 over 4 take 2 over 3. And next we're going to turn this into a problem of addition. To do this, we'll start off and we'll go 5 over 4, then we'll just change it to plus. But this plus will have a consequence. The negative over here, we're going to give it to the 2 in the numerator here, so it becomes minus 2 upstairs and 3 downstairs. Now we can simply just use the butterfly method. Working this out, I get my two denominators and I'm going to multiply them together. This will become 4 times 3. Next, I get my first numerator and multiply it with my second denominator. This will be 5 by 3, and then it's plus. Finally, I get my first denominator and multiply it with my second numerator, which happens to be negative now, so it's 4 by minus 2. Calculating this out, I know that 4 by 3 is 12, 5 by 3 is 15, plus, and 4 by minus 2 is 8, or minus 8. So what we discover is it's 15 plus minus 8. 15 plus minus 8 is the same as saying 15 take 8, which is the same as saying 7 over 12. And thus we arrive at our simplest answer here. Because I know 7 is a prime number and 12 has the factors of 2, 2 and 3, I can't simplify this any further. So what we've got is the addition of 5 over 4 plus negative 2 over 3, or 5 over 4 take 2 over 3. So we have implicitly learned how to do fractional subtraction by just following the addition algorithm. Alright, let's go one degree of complexity higher. we have minus 5 over 2, take 1 over 3. The way in which we're going to solve this is exactly how we just did the previous one. We start off and we were at 5 over 2, take 1 over 3. And we're going to convert these fractions into negative fractions. So it's going to be minus 5 over 2 plus minus 1 over 3. Now we use our butterfly method. Two denominators will come together and that will give us 2 times 3. After which, first numerator will be multiplied with the second denominator. Minus 5 multiplied by 3 plus first denominator multiplied with second numerator, which will be 2 times minus 1. Simplifying this, downstairs 2 3s are 6, upstairs 5 3s are 15, but it's negative 15, plus 2 1s are 2, but because it's negative 2. And then simplifying this further, we've got minus 15 plus minus 2, which is the same as saying minus 15 minus 2. Now I know 15 plus 2 is 17, but because they're both negative, it's going to be minus 17 over 6, which I can write out as negative 17 over 6. So we are able to subtract a negative fraction from a negative fraction. Nice and easy. Alright, final one. We have minus 1 over 4, take negative 2 over 3. We're dealing with a double negative here, but that's not a problem because we can do this just like every other one we've done so far. It's minus 1 over 4, take negative 2 over 3. Now if I think back to my integer rules, I know that minus 1 over 4 and double negative is going to turn into a positive, so it's just a plus. So it becomes minus 1 over 4 plus 2 over 3. Now I've got the option, if I wanted I could go and shuffle the two fractions around, so this term goes over here and this one over here, and then it becomes just like our second example. Or we can keep it in the order we have up here and we can see how that works out, which we'll do in this one. So it will be minus 1 over 4 plus 2 over 3, then bringing our two denominators together, 4 times 3, first numerator, second denominator, minus 1 and 3 plus second denominator, first denominator, second numerator, 4 over 2, 1 3 is a 1, or 1 3 is a 3, it's negative so it's minus 3, plus 4 2s are 8, that's all over 4 3s which are 12. Bringing this together, 3 or minus 3 plus 8 is the same as saying 8 take 3, and that will be 5 over 12. And we simply know because 5 is a prime number and 12 is not divisible by 5, this is as simple as it gets here. So in summary, what we had to look at was how we could deal with a negative fraction, take away another negative fraction. So this is as complicated as it gets. So the way in which we add fractions together is, firstly, if it's a negative fraction, just turn it, or if it's a subtraction, just turn it into a negative fraction by taking the negative from out front to upstairs. And then you simply use the butterfly method, that being multiply the denominators together, then cross multiply numerators and denominators. Add the numerators up, and then if you need to, simplify like we were doing in the previous video.